Hello, 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 everybody. So here's another quick little video, little tutorial, a way to rotate something, which can be a bit of a pain in the ass to do. So let's get started with that. So what I mean is, let's say you have a bunch of objects, and you want them to rotate. So you have them as like a packed object, and you want them to rotate somehow. And obviously, you can always use a transform and just rotate, but this is not always going to be something you can do. So let's make just a dumb example here, and let's just make this longer, maybe 30, maybe something like this. Cool. I'm just going to I don't know, let's say split points, poly extrude them. We have a bunch of plates here, output back, so they are, solid. Maybe we can make them a little bit, like give them some gap. We can use a primitive for this, primitive properties, and just do transform and just scale it down like so. Cool. And let's add a sphere. I'm gonna make this into a point, so just primitive. This is gonna make it into a point. Let's also move it. So it's something like this. And I'm just gonna animate this value. Something like so. I'm just alt clicking basically to keyframe it. So we got that. Very exciting, I know. And let's now assemble this so they are packed, which is nice. If you want to do simulation and shit, it's nice for other things as well. So with attribute wrangle, and here comes the wrangle again, the damn VEX. So what we get here, we want to have the position of our sphere, and we want, when it gets close, we want these to rotate. So let's first get the position of our sphere. So let's use a point function. The first one is usually the input, right? So 1 being the second one, 0 being the first one. We want to take the sphere, which is here. So therefore we set 1, and I want to get the P attribute, which is the position, capital P. And we only have 1 point because we made it into a primitive. So it's just 1 point. So now we have the position. We can also get the distance while we're here. So float, let's call it dist, and it's just a distance function. Basically, we take the position that we have here of our sphere, and then the position of each of our plates here, and that gives us a distance. We're not going to be able to see it in the spreadsheet here because we are making variables. You can only see attributes, but you're just going to have to trust me on this one. So now to rotate these, we're going to have to use prim intrinsics, the transform. So it's a matrix 3. Normally you just call it M, so I'm going to call it M. We can either use a ident. This is going to just initialize our matrix, or this would be, I believe, the same as prim intrinsic 0 transform and then PT. Now I believe this is the same thing. I'm not sure, don't quote me on it. We can use this or we can use the ident. Let's just use the ident because it's shorter, I guess. We want to have a vector, axis. Let's call it axis. And for now, I'm just gonna put in an axis. Let's just do up. And then we have a float, which is gonna be the angle. We wanna convert this value with the radians. This is gonna just be, it's just simpler. If I type in 45, it's gonna be 45 degrees. Normally it would be like, 0 point whatever, right? This is just basically converting it. So it's, easier to work with value. 45 degrees is 45 degrees. Cool. What else do we need to do? We need to rotate, right? So we're going to use a rotate function. And this one basically says, I want to modify the M that we have here. So we put it in like so. And then I believe it's the angle and then the axis. Yes, no errors. So we're good to go with that one. Now, one thing we want to do to make sure is to actually normalize the axis, because this is also it's gonna scale our stuff if we get big values. So we can just normalize it. You don't have to normalize it here. You can normalize it here if you want to, but whatever you feel like. And then basically we need to write this into our prim intrinsics. Basically, prim intrinsic is like packed away values, which is just more of a pain in the ass to work with. But I'm sure there's optimization reasons and whatever else. So we can use a set prim intrinsic function, and let's see if I get this right. So it's first it's a 0, which is going to be our plates basically. Then we want to do the transform. Then it's the point number, and then it's the M. And there is another one which is like set, multiply, etc. I believe set is the default. And as you can see, we are getting rotation here. So transform, if we go to the primitives, we can see we have transform somewhere. There it is. So that works. But let's, of course, rotate these based on our sphere here. So the angle, this one can be, this is going to be the amount. So we want to fit this, of course, because if we're not fitting it, it's going to rotate everything, which we don't want. So we want to fit the dist, and original value is from 0 to however long of a distance you want to actually like how far is it going to modify this. So let's just say, I don't know, 2.5, and we're gonna say, let's say 90 degrees if you are 0, and 0 degrees if you are higher than this. Or I guess this would be this, and anything in between. If we were to play now, we're getting this. So it works. Let's also do the axis. I think, what can we do? We could try pos minus our position. What would that give us? Something like that. Not sure if it's interesting. We can cross it. So cross needs 2 axes. It's going to give us a third axis. Let's just go with an up vector here. Let's see what that gives us. That's something. Maybe we can invert it. Not sure if that was any better. But that is something. So we are rotating now. Very simple. We can also, we could, you know, why not? You know, DOP network. I love me some DOP network. So let's drop in a packed, rigid, merge, ground. Drop these in like so. Make sure it's on the correct order here. First context, let's also make like a, well, let's first not do that. I'm gonna show you something. We do need to basically say like create deform active objects, otherwise not much is gonna happen. And now we get this. Now the problem here is a lot of the times they're kind of, well, they don't seem to do that now, but sometimes they can freeze, like go to sleep. So if you have issue with that, you can maybe lowering the enable sleep value or even turn it off if you want to, but it's a good thing to have on. Let's add a pop force. I'm just gonna do that and we get that. Kind of fun. I don't know if it's useful. Let's make some more. I just want to look at it like so. Just gonna crank this up a little, something like that. Let's also just view this and play. And we get this. Yay. Look how cool. And you know, so you can adjust the how far you want them to rotate. Looks kind of funky. Yeah, that's basically all. Quick and short tutorial, I think. There are other ways of rotating things, but you know, this is one of them. Yep.